me just make sure everything looks like everything's working okay. All right. Well, there's a small blessing. Okie doke. So, I mentioned on Monday, and I apologize, I've not uploaded the video I recorded with y'all for Monday just yet. I'm going to try to get this video and the one for Monday uploaded today. Just, things pop up, get in the way. Okay, so today we're going to be looking at some textbook problems. Okay, now if you go into Moodle, let me get this thrown over here. And then let me get this zigged and zagged. All right, so if you go into Moodle, over here on the left, remember up towards the top, there is a textbook section. Click on that. All right. I think that I've got this set to force download. Yes, something I did actually remember to fix. It'll take it a minute or two. Pretty big old file. All right. So while that's downloading, you can go ahead and get your notebooks ready. All of that good stuff. So we're going to look over a couple of practice problems involving box plots and scatter plots. All right, and we're going to try to go through those really quickly so that we can look at the lab itself before y'all leave, since we didn't get a chance to do that on Monday. Yeah, right. So go away. I've had to migrate over everything to a different Google account, and it just keeps asking me, do you want this? Do you want that? No, leave me alone. Okay, so a quick way to kind of get through this book, over here on the left, if it pops up this way for you, I know Adobe is a little bit picky, but I clicked on this over here that kind of looks like a table of contents, and I'm going to go here to where it says Part 3, Probability and Statistics. All right. So chapter 5, we're going to put on hold just for a second because that's where all the scatter plot stuff is in chapter 5. So go to chapter 6 where it says putting statistics to work, and then we're going to expand that out and go to 6B. 6B, measures of variation. All right, so that's where we need to be. It's a little bit easier to kind of navigate this thing that way as opposed to, why is this not, okay, well, as opposed to like trying to find the actual page, because the actual page that we need is page, where is it? I thought it was 374. Nope, not 374. Where did we, oh gosh. Okay, sorry, 376. 376, all right? So it's 376 in the actual textbook, but on the document, it's page 403. Because it's a textbook, there's like 20-something pages of bibliographical stuff at the front. So it's easier to kind of search through this little sidebar over here. Okay, so right here in the middle, which looks like the typo is on the on the digital copy too. But anyway, right here on the middle, right where it says drawing a box plot, you can add that to your notes if you wish. If you like that explanation of how to draw it a little bit better than what I gave you. But it basically kind of says the same thing. So step 1, which by the way, that's supposed to say drawing. Hope a proofreader got a pay cut for that one. So drawing a box plot, step 1, like we talked about on Monday. draw a number line that spans all the values of the data set. You want it to start before your lower extreme and end after your upper extreme, okay? So that's what in the book it talks about with a range. You want to set up a range that fits everything. Then enclose the values from the lower to the upper quartile in a box. So in my notes, remember I wrote draw a box around the quartiles. Same thing. Draw a vertical line through the box at the median, and then add whiskers extending to the, they call them the low and high values. We'll call it the lower and upper extreme. And we're going to draw a box plot today that will show you that, you know, sometimes outliers are extremes. Or I guess I should say sometimes extremes are outliers and sometimes they're not. Sometimes they're pretty close. But we'll look at it, okay? The example I wanted to do with you guys was the same one that I did in Andrews this morning. I took standard deviation out for several reasons, but our official reason is going to be we're going to let 152 handle that, all right? Because we got to, you know, our plate's pretty full. Okay, so which one did I do? Oh, it was 18. Okay, so let's look at 18 out of the textbook, okay? And so what I'll do is I will put this on this screen, and I'm going to flip the recording to the whiteboard for a few minutes while those numbers are still up there. All right, so in this section that number 18 is in, it says take this information, build a box plot, okay? Now, it probably said to, you know, build one for Beethoven and build one for Mahler and then compare them. It may not have said that. I don't know. If I'm being honest, I found one that didn't have any decimals and used it as an example. Sue me. All right, so we're going to take all 18 of those values and do a box plot, okay? So this was on page, anybody see what page it was on? Thank you very much, 382. Okay, so page 382, number 18, okay? Now, we talked on Monday, what is the first thing you always do when you're dealing with 5-number summary? It's the first thing you do before you find any of the 5 numbers. Put them in order, right. So let's look through that list over there. What's the smallest number that you see? 26. All right, so I'm going to write 26 here. I'm going to be definitely getting my steps in the next few minutes. So I'm going to take that 26, I'm going to mark through it on this list so that I know not to count it again. What's the next one after 26? 28. So 28. 28. Whoa! All right, what's after 28? 30. All right, 30. Which one's after 30? 33. All right. I've got 36 and 38 as the next two. Is that right? Or did I miss one? I missed 38 this morning in Andrews because I had to, you know, my Wi-Fi wasn't working, so I had to copy it out of the actual textbook. Okay, I've got 40 and 50 as the next two. And there are two 50s. So 40, 50, 50. All right, 52 and 68. Is that right? There's not one in between there, is there? It's a pretty good gap. And then two 72s. Two 80s. $85, 90, and 94. 85, 90, 94. Kind of got tight towards the end there. But anyway, all right. So we should have 18 of these, unless I wrote a couple of them down twice when I wasn't supposed to. 1, 2, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, we're getting good shape. All right, now remember we talked on Monday, and again, I've got to get for the online folks. We talked on Monday that there are two ways to organize your 5-number summary. There's to find them than there is to graph. Okay, so first, let's find it. All right, so find the 5-number summary. Okay, when you're finding it, the order goes lower extreme, upper extreme, median, up, not upper quartile just yet. Lower quartile, upper quartile. Okay? Now, first, the lower extreme and the upper extreme are going to be really easy. It's your first and last number, right? So our lower extreme is what? 26. And our upper extreme is 94. Okay. Median, got 18 numbers. It's an even number set. So with an even number set, you count from the ends and then find the two that are in the middle. Well, half of 18 is 9. You're looking for 9th and 10th numbers, right? So in this case, the 9th and 10th numbers are right here, 50 and 52. Okay? Well, what's in between 50 and 52? I heard it whispered softly. 51, yes. So 51, remember we said that's sort of like a floating or imaginary median in that that is the actual median, but it was not included with the original number set. Okay? So median is going to go here. Now, the lower quartile is the median of the lower half of the numbers. We've got 9 numbers in the lower half. So 1, 2, 3, 4. There is a number right in the middle. So there's 36 for our lower quartile. Do the same thing for the upper quartile. 1, 2. There is a number right in between there. So the upper quartile is 80. Okay? So now that we've found them, the second thing we got to do is you have to make the box plot. Okay? Now remember, putting them on the plot or putting them on the number line, there is a different order for that. So we've got lower extreme first, then lower quartile, then median, then upper quartile, and then upper extreme. All right? I'm going to go ahead and color code this next bit. That is as soon as I figure out what happened with my green marker. There it is. Okay. All right. So I'm going to do the extremes in blue. So our lower extreme is 26. I'll do the quartiles in green. All right. So our lower quartile is 36. I'll do the median in red. Our median is 51. Back to quartile. Our upper quartile is 80. And then back to blue, our upper extreme is 94. All right? Basically, what I'm trying to get across is you should put them in numerical order before you graph them. Make your job a little bit easier. Okay? Hopefully that was a little bit clearer that time. All right, so then you have to make yourself a number line. All right? Boy, I hope I don't knock this out of my hand. I've done that. Oh, God. Yep, all right, off to a great start. All right, That's not very big, but hopefully it shows up. Okay. Again, like the textbook said, and like I was telling you on Monday, you want to, I did get y'all's video uploaded. It was yesterday's group that I didn't get uploaded. Sorry. I need a secretary. I can't remember everything. Set your range for your number line wide enough that it'll fit all 5 of these numbers. So your lowest number is 26. You can start 20, 25, whatever you want to do. I would start at 25. Okay. Your upper extreme is 94. 95 would work, right? Now, depending on how spaced out that you would want to make this, you could go up by 5s or you could go up by 10s. I think this morning at Andrews, we went up by 10s. You could go by 5s if you want to. You might need a little bit longer number line. So, all right. So let's go 35, 45, 55, 65, 75, 85, 95. There, fixed. Okay. So, first things first. Just kind of jot these down as you go, left to right. All right. I'm going to color code them for y'all's convenience. I mean, y'all don't have to unless you just want to. So 26, well, 26 will be just past 25. Next, lower quartile of 36. So 36 will be right there. Your median is 51. So 51, well, 50 is right here. So 51 will be a little bit off center right there to the right. Your upper quartile is exactly 80, so it should be right in between 75 and 85. And then your upper extreme of 94 will go just before you get to 95. Okay, so the box goes around the quartiles. I could get the yardstick back out, but I'm just going to save a little bit of time. All right. So the box goes around the quartiles. The line goes through the median. And then the whiskers go to the extremes. Okay. Now, if it were to ask you a question of, are either of your extremes, either of your lower highest values, I would say 26 probably not, 94 maybe. Like I said, there's not really any set establishment that says, if it's past 10, it's an outlier. If it's past 15, it's an outlier. I mean, some places may say that on the instructions, but I've never seen it just like as a general rule. All right. So again, this was with an even number set. All right. Any questions dealing with this? Anybody still copying this down? Anybody need a picture? Okay. I want to try to do a real quick one with an odd number set so that we can get to the what the lab looks like. Good Lord. My brain is not working. Okay. Now this next one, I'm just going to make it up. Okay. So at the beginning, Monday, when we were talking about mean, median, and mode, things like that, I mentioned that there are some instances where if you're trying to interpret data so you can present it to somebody else and make a case for your argument, you might want to use one or the other. You might not want to use mean every time. You might want to use median because it might make a better graphic or, make more sense. So I'm going to throw 7 numbers up here, okay? All right. We did 11 at Andrews this morning, but let's dial it back. So let's do 800, 700, 1125, 1370, 1900, 1450, and then let's do 4700. Okay? So this is an odd set. All right, the last one was an even set. This is an odd set. So, the first thing that we have to do before we find our 5-number summary and make our box plot is we got to do what with those numbers? Put them in order, okay? So we're going to start with 700, then we'll do 800, and then looks like 1125 is next, followed by 1370, then 1450, then 1900, and then 4700. So the problem that I'm kind of parroting here is there was a question in the old one of the old 110 books that said you work payroll for your company, you got to send it out every month. You've got like 11 salaries that you've got to send out. If you're trying to tell an auditor what your, like what most everybody is, what the, you know, like what most employees are making at your company, would you use the mean or would you use the median? Okay. Now we're not going to find the mean, but I am going to show you in a little bit. Okay, so our lower extreme is going to be 700. Our upper extreme is 4,700. All right. And then our median, well, odd number set, so there should be a number sitting exactly in the middle, right? We had 7 numbers, so count from the ends until you get to the middle. So 1, 2, 3, 1470 is right in the middle for your median. Now, the reason, or 1370, I think I said 14, sorry. 1370 is right in the middle. Now, the reason why I put is because you have to, if it's an odd number set, to exclude that number from your halves so that you can find your quartiles. Okay? Otherwise, you don't want to count it twice and mess yourself up. So, now that we've divided this in half, for our lower quartile, we've got 700, 800, 1125. So we only had 3. So 800 is our lower quartile. For the upper one, 1450, 900, 4700, 1900, or 1900 rather. I can't read today either. So that's your upper quartile. So now you found your 5 numbers, put them in order before you graph them. Okay? So that is numerical order. So our lower extreme is 700. Our upper extreme, 4700. Nope. I was just copying it verbatim like a moron. All right. Our lower quartile, rather, is 800. Our median is 1370. Our upper quartile is 1900. And then our upper extreme is where the 4700 goes. Okay. All right. So, now let's set up our number line. Our lowest number is 700. Our highest number is 4,700. That's of 4,000. So, I mean, technically, you could start with your lowest number if you wanted to. I mean, if it was something convenient like this. But your increments is where it's going to be a little bit crucial. I don't think that if we went up by 100, we would have enough room. We could try 500 and see how that looks, or we could go up by 1,000. But in terms of scale, what happens is if you, like, the bigger the increment that you go up by, it's like you're zooming out. So it's going to make everything look really crammed together. Whereas opposed to if you go by smaller increments, it kind of widens out a little bit. So do you want to try using 500? That seems like a pretty happy medium there. All right. So we'll start with 700. And we'll go up by 500 every time. So 1,200, 1,700, 2,200, 2,700, 3,200, 3,700, 4,200, 4,700. Hey, it worked out pretty well. All right, not too shabby. Okie doke. So now mark your 5 numbers. So lower extreme is at 700. This time I'm going to make sure I leave myself enough room to actually draw a box. So the lower quartile is 800. That's going to be very, very close to your lower extreme. And by very, very close, I mean very, very close. Okay? Then for your median, you've got 1,370. Well, here's 12. 13 is going to be a little bit past it. 1,370, you're looking somewhere in that area. So you're just kind of eyeballing it. All right, your upper quartile, 1,900. Well, here's 1,700, here's 2,200. So 1,900 is liable to be just before halfway on that. And then 4,700 is all the way down here. Okay, so then we follow our steps. The quartiles get the box. Okay. The median gets a line through it. And then your extremes, or your low and high value, get whiskers. Okay. So conclusions that you can draw from this one is that there is definitely one out there compared to the rest of these, right? So since you have one that's so much more than the majority, would averaging all of these give you an accurate representation if you're trying to tell someone, here's what the typical person makes at our company each month? No, because you've got one that's got 29 and a half years in and is fixing to retire, that has a high salary and is pulling the average way too high. Whereas if you looked at the median, that's pretty much right in the thick of things, right? So in this instance, the median would be a better representation of the general populace of your company. All right. So any questions about that one? Okay. Real quick. Oh no, we have lost internet. Oh joy, joy. Well, let's see if it'll come back. I swear if it's not one thing, it is something else. All right, well, while that's seeing if it wants to work today, let's go to the scatter plot stuff. So in your textbook doc, back to chapter 5, statistical reasoning. All right. And you're going to go to the end of the unit. You know what? I probably should have just done this. Go backwards. Okay. Yeah, that's what I should have done. All right. So let's look at number 13. Okay. Model cars. Okay. So what it's measuring is two things. Of course, scatter plots always measure two things. The first thing that it's going to measure, oops, let me fix this for the video. First thing that it's going to measure is the weight of the car. The weight of the car is going across the x-axis. Up the y-axis is city gas mileage, or miles per gallon. We remember miles per gallon all the way back from the conversions lab. So, looking at this graph, what are a couple of things that you can tell me about it? It is going down, which means it's what kind of scatter plot? Negative. The definition of a negative scatter plot is that as one value is going up, the other value is going down. Which one's increasing? Yeesh. Sorry, I should have just left it alone. Which one is increasing on this graph? Right. There's a trick question on scatter plots. X is always increasing. Okay, the X value is always increasing. It's the Y that will change depending on the relationship. This relationship is saying the heavier the car, the lower the gas mileage it's going to be. Right? I mean, which one are you going to take on vacation? A four-door hybrid or a cement truck? The four-door hybrid. Because if you say, all right, kids, we're going on vacation, hop in the cement mixer, lots of problems. Lots of problems. All right? So, yeah, the lighter it is will actually give it a better gas mileage. So this is clearly a negative relationship, about messed everything up. Now, we're not covering it for our purposes, but if we were following the textbook recommendation, we would say this is a strong negative correlation, right? Because you can look at it, clearly see it's negative. Okay? All right, number 14. Okay. 14 is comparing voter turnout to unemployment percentage. Okay? Now, first glance at that one, what would you say? All right, Riley says positive. Does anybody else think it's positive? You don't think it's positive. What do you think it is? Yeah, that's the one I'm looking for. Okay? And so now, since, Riley was kind of on the fence of it being positive or no correlation, now you see the trouble with doing weak positive or strong positive or stuff like that. Okay? The book logic is saying if you were to cover up those 2 points like they weren't even there, then you could say, oh, it's positive. But there's a problem. Those 2 points are there, aren't they? And we're not just going to throw them away just because they were late to the party. Okay? So in general, you would say it's not strong enough for this to say, oh, well, voter turnout is tied to unemployment rate. Okay. So anyway, this one I would say no relationship, no correlation. Okay. Yeah, every blessed class. All right. 15. Charitable giving across 11 states as percentage of adjusted gross income. So your average adjusted gross income, and then percent of it that you're giving away. What is this one saying? Nothing. The answer is nothing. There is no relationship here. All right? Just because you make more, it doesn't have a determination as to how much you give. I make plenty and I'm very stingy. Just being honest. Yeah, Alex, like, that's how you keep your money. Like, you're easy there, Alex. 16 says, U.S. farms 1950 to 2010. It's comparing the number of farms in the millions to the average size of the farms in acres. Okay? This is a representation of a limitation of space. There's only so much farmland available, right? Well, if you're going to have more farms, what has to happen to the size of land you have? You got to divide it up. You got to sell it off. In other words, they're going to have to get smaller. We're not getting new land. There's not volcanoes erupting right and left making new land masses. Okay? There's a little science for you. But anyway, so yeah, this one is clearly what? Negative, yes. As the number of farms increased, their size had to go down because there's only so much room. Okay, so you're also going to see some questions like this that say types of correlation. Okay, so like 17, latitude north of the equator and average high temperature in June. So basically what it's saying is, as you travel from, say, Ecuador to Greenland, what's going to happen to the June temperatures? They're going to decrease. Right, so as your distance from the equator increases, the temperature is going to go down. One's going up, one's going down. This is, if one's going up and the other one's going down, what kind of relationship is it? Negative. Thank you, Ian. Yes, negative. 18, height of a person and how frequently he or she attends religious services. Yeah, that is textbook no correlation. Okay? You can't look at Emma and Gwen and say, well, Emma's doing great because she goes to church all the time. I mean, look how tall she is now. That's not how it works. Or, I mean, you couldn't say, well, sorry, Gwen, your future is mighty hot because you're not that tall. All right? That's not how that works. So there's no correlation here. Okay? Age of a person and time spent on social networking sites. It does. What would it be? Okay, so the younger you are, the more time you spend, and as you get older, less time. So as your age increases, the time you spend on social media goes down. So as one goes up, the other goes down. That is negative. Now, of course, notice that it didn't say anything about arguing about politics on Facebook. That would make it pretty flat, so that would be no correlation. Okay? Weight of a person and shoe size. This one is very poorly worded. What it is saying is what happens to your shoe size as you grow up. As you grow up, as you go older, you gain weight, your feet get bigger. So as you gain weight, growing up, it should say, your shoe size gets bigger. One goes up, the other goes up. This is positive, right? Fertility rate of women and life expectancy in a country. Okay, so this one, there was an example like this earlier in the book that we'll try to go look at here in a second if we have time. But it was talking about, you know, if you live longer, what are your chances of, you know, producing offspring? This one would be the argument of like a weak positive, because you know everybody's body's different, but it's kind of saying, you know, if people or women in particular in this case live longer, they're more likely to produce offspring, right? I know it's very, very argumentative. That's why I don't like doing the weak positive, weak negative. And then 24, average property tax in a school district and average salary of high school teachers. Well, it might. And the fact that it might is kind of why I didn't want to do the strong and weak stuff. I mean, just because you're paying out the nose in property taxes doesn't mean that that money is going to education. You know, we're paying out the nose in property taxes right now because of that DSS mess a couple of years ago. Sorry if that hurt some feelings, but that's what happened. Okay? All right. So, there's that. All right. Internet's back on. Thank you, Lord. All right, so let's go look at your work, your question page for this. So hop over to Stats Lab. We're going to go down. Yeah, so I did upload Monday's class. Okay, thank goodness. Okay, so click on where it says student copy. All right. Okie dokie. So, oh, sorry. One thing I didn't address. My bad. I'm poorly prepared, horrible teacher. Run, little hamsters, run. Come on, there we go. All right. Note the directions for the work entry, please. Oh, for the love of God! Come on. All right. Don't tempt me. All right. So here you can upload either the handwritten work for questions 7 through 16 written on the student copy, meaning like if you're doing like Alex and you're going to print it out and write it on there, that's fine. I'll take it. Just make sure that you take a picture, scan it, whatever. Or if you want to do it on a separate piece of paper, I'll take that too. Just please, and I'm talking primarily to the online people, number your questions. Okay? Number your questions. Please do not take a picture with a webcam, laptop, or Chromebook camera. The quality is very poor and difficult to see, and I've already been doing this. If I can't read it, I'm not grading it. Plain and simple. Okay? Don't upload a blank version of the student copy. I can understand doing it once accidentally. 3 times you have a problem. Don't upload a blank copy. Okay? And don't correct your work entry after you turn in the answer entry and find out that you got a couple wrong. That's not when corrections are for. We've got another week of corrections coming up towards the end of the year. Okay? That's when we correct. Okay. Answer entry directions. Answer these to the best of your ability. Remember, the choices on the answer entry are going to be in a different order than the student copy. So just because A on the student copy says a certain thing, that's not going to be the same thing in the answer entry, okay? Also, the correct answer will not show upon completion. This is to deter people from correcting the work entry and uploading it after. Haha, gotcha. All right, so now let's go to the worksheet really quick, like 3 minutes quick. Lightning speed. Lightning speed, Moodle, please. All right. So, the reason why I said 7 through 16 is because 1, 2, and 3, you have scatter plots. You've got to tell me what kind it is. Very simple, okay? It's one of 3 things. It's positive, it's negative, or it's nothing. All right? 4, 5, and 6, you've got 3 questions. Give me positive, negative, or no correlation based off of these scenarios. Now in the spring, there was one that people kept arguing with me about. I think it was number 5. All right. So, just answer these to the, the best of your ability. If you know anything about computers, then 4 is going to be pretty easy for you. If you don't, you might want to look it up. Okay. I will say this. Computers age like cars. I'll leave it at that. Okay. So, 7. Last year, 9 employees of an okay, so you've got these 9 numbers, and it tells you what to find. On 7, you're finding the mean. Okay, add them up, divide by 9. 8, you're finding the median. Okay, put them in order if they're not already, and then find the median. All right. 9, the blood types for 30 people who had agreed to participate in a medical study were as follows. Find the mode. Okay, you might think you can look at it and figure it out. Put them in order though. Okay, what I would do is I would make sure that after I put them in order, I had the right number of A's and B's and AB's and O's. Okay. 10, Find the weekly salaries are given for 16 government workers. Your direction, obtain the 5-number summary for this data. 10 is where you're going to start being very, very careful here, okay? Because the answer choices are not going to be that different. It's going to be very, very subtle differences. Like, for instance, look at A and C. A, you've got 456 and 456, 435.25, 443.5, 615, 629, and so on. So make sure that you're looking at these very carefully. Make sure that you're calculating them to the best of your ability. Please use a calculator. Same thing for 11 and 12. The numbers are given out of the set. 13, 14, 15, and 16. These are the most difficult ones. And let me tell you why. You've got to make a box plot. Okay? That's what the direction says. What you're actually doing is you are checking the ones that are already made to see if they're correct. Okay? Welcome to my weekly uphill battle. All right? My suggestion to you for 13 through 16, make your own box plot and then check it against the 4 choices. Now, you're not just checking to see how it looks, okay? Because if you're just checking its looks, A and B look identical, don't they? Look at their 5 numbers, though. Their 5 numbers are ever so slightly different, okay? So you want to make sure that you are rounding correctly, that you're figuring these up correctly, okay? The most common complaint I got about this one in the spring was I did my box plot and I didn't have one that matched any of these. And I was like, well, then you did something wrong, because it's one of them, all right? So, I mean, that's all I can tell you. Double check your numbers, okay? And then just, look at it to see if it makes sense, okay? I mean, not to, give the milk away for free here, but is 7 going to be closer to 7.7 or 6.4? And that's all I'm going to say, okay? Little things are going to get you on these. All right, so again, make your own box plot. We went through 2 of them. I've got a video from the spring embedded where we went over 2 more of them. Make your own box plot. If you want to print this out and write on it, you got plenty of room over here, okay? And then, again, you're not just checking its appearance. You're checking your numbers, okay? Because as you can see, some of these numbers might just be off by 1 or as much as 4, okay? So you've got to be very meticulous with these, okay? Jackie, do you have a question? Okay. Any questions about this? All right, I held you over 2 minutes. So Monday, remind me you get out 2 minutes early. We'll see you.